Hello, Cormac Allen here again. In this presentation I will take you through some samples of work from first year of the TU831 Architectural Technology programme. In first year, the student is introduced to the principles of building materials and technology and is encouraged to develop a capacity to identify and resolve architectural technology problems. This is done primarily through the Technical Design Studio module, which focuses on the technology used in masonry construction. Studio projects are designed to enable our students to investigate and explore materials and construction techniques employed in the construction of what we call a domestic structure, or a house in plain English. In Semester 1, students are introduced to the elements of construction. They explore different parts of a typical house, including foundations, walls, windows and door openings, using sketches and models. In Semester 1, students are also introduced to building information modelling using Autodesk Revit. This is a complex software which takes time to master. It's taught in each of the 4 years of the programme, starting on day 1 in first year. By Christmas, students are able to produce a digital model for a small single-storey building using their developing understanding of building construction from Technical Design Studio. The model contains digital data and is used to extract drawings, schedules and 3D renderings. The main focus of first year is the house project, which brings together all the skills developed over the 2 semesters. By the end of the year, students can produce a digital BIM model for a 2-storey house. It's always impressive to see how quickly our students develop these skills. It's not easy and requires hard work, but the result is clear to see. I will take you through a typical house project now. On each project, students start with an initial sketch-based technical investigation. We call this process of investigation through sketches the esquisse. This is a French word for a rough or preliminary sketch. We consider this a vital tool in the technical design process, and it is an important and necessary process alongside digital modelling. Students are issued with a brief including a diagram of the building, which they then investigate and develop using freehand and overlaying hand drawings. Within this, technical issues are teased out loosely before committing to a BIM model. If you go straight to the BIM model, the design will be limited and unresolved. These drawings investigate the general layout, including joist layouts and roof trusses. These sketch drawings are more developed and show more detail. Looking closely, you can see how the joist plan has developed from the previous iteration. The word iteration is important. Design is an iterative process. It involves the ongoing investigation and development of a technical problem to a point of resolution. Studio is based on this project-based iterative design process. It's the bread and butter of our programme. This is a yet more developed pencil drawing, which is examining the construction details in an overall large-scale section. These sketch drawings inform the digital model, which the student is now developing in parallel with the iterative sketch-based technical design process. Even though we are increasingly dominated by digital media, there is still an important place for pencil and paper, and we celebrate this. As mentioned, the BIM model is essentially a digital database, with the student in effect programming the model with construction information. Technical drawings, schedules and 3D renderings are extracted from the model and presented as conventional drawings, which can be viewed digitally or printed on paper. This is a drawing showing the foundation and ground floor plan of the house. It's called a general arrangement drawing and includes things like grid lines, section lines, dimensions, drainage layouts and notation describing key elements. This is the general arrangement drawing showing the first floor plan of the house. This includes the joist layout, which you will recognise from the esquisse drawings. With my eagle eye, I can see that there is a wall missing from the middle of the joist plan. This would have been pointed out to the student as part of their feedback. And these are general arrangement drawings of the loft and roof, showing both finishes and the construction underneath. All of these drawings are extracted from the BIM model, so all of this information will have been created in 3D and then extracted as 2D drawings. These are general arrangement elevation drawings. They have been set up to print at a scale of 1:50. You can see the use of grid lines and level lines, which confirm dimensions and relate back to the GA plans. All of this follows what are industry conventions. And this is a 1:20 cross section. You can see that this offers more detail and explains the overall construction technologies used in the house. Note the insulation, which runs continuously under the floor, up through the walls and across the attic, providing an unbroken thermal envelope. And here's another 1:20 section, this time including information on window openings in the wall. And here is another 1:20 section, this time including information on the single-story flat roof kitchen. Again, note the unbroken thermal envelope. The 1:20 sections describe the overall construction, but more detailed drawings are required to describe each part of the building. These are detailed drawings of the foundation and rising wall and the window head, sill and jamb at a scale of 1:5. And here are detailed drawings of the roof, eaves and verge, again at a scale of 1:5. And while the BIM model is used to create drawings, it is also used to create schedules of components. This is a window schedule, with each window described in elevation and section and including specification and dimensions. And here is the door schedule. There was a time when this had to be drawn by hand, but it can now be generated in an instant as long as the BIM model has been programmed accurately with the required technical data. And here is yet another aspect of the house project. This is a building services layout drawing showing electrical layouts and drainage. And finally, here is the site plan showing the building in context and indicating drainage layouts and connections to the public sewers on the adjacent road. And here are some of the class of 2021 who at this moment are working away on the kinds of projects which I have outlined in this presentation. My next presentation will look at the work of second year students, showing how these skills are further developed on commercial and industrial projects.